So I'm Gordon Hamilton. I'm the director of Math Pickle, and this week I am proud to say that I am the designer of Santorini, my first Kickstarter. 6 years ago, I came to my first Gathering for Gardener, and there I met Neil Sloan. He gave a brilliant talk, and I went home and started to introduce more and more integer sequences into the K-12 classroom. However, for teachers, if they go on the online Encyclopedia of Integer Sequences, they are stumped. This is an impenetrable site for most K-12 teachers. So the obvious solution was to select 13 integer sequences, one for each grade, and we did that at a conference last year in the Banff International Research Station. I'm going to go through grades 1 through grade 6 in this talk. I'll let you guess what this sequence is. Okay, so this is A4 is equal to 3, A5 is equal to 6, A6 is equal to 10, and A7 is equal to 20. So these are the polyominoes that have bilateral symmetry. In the left circle, you have horizontal. In the right circle, you have diagonal cuts. And why did we choose those? Because an average kindergarten grade 1 teacher might want to count polyominoes, but you're going to have children asking, is this L shape the same as this L shape? And the teachers often couldn't pick it up and move it around. So it was much easier to choose ones that had mirror symmetry. So that's our grade 1 sequence. Grade 2, we're going to play it on a 8x8 Go board, but it's nothing to do with Go. Here are the chips. There's 20 of those. I tell kids that there's 64 kids, and these are the ones you send home so that they don't get sick. And the largest remaining subset that is all connected, those are the students that get sick. So here we have 8. That's the largest. This is only 7. This is only 7. This is 8. So the score here for the virus is 28. And the kids have to try to find a way to get this score for the virus as low as possible. And indeed they can. 28 is too high. Here is one where they can get down to 26. And you can do even better than this. You can do this, which is 11.25. That's as good as I could do on the 8x8. So A8 is less than or equal to 25. A9 is less than or equal to 29. A10 is less than or equal to 36. And I have found, but I am not going to divulge, my optimal solution for 11 by 11. Whenever I'm introducing this to a grade 2 classroom, I introduce starting with a smaller problem. Maybe it's even just linear instead of a square. But this is where kids end up. The grade 3, we are going to look at a starting seed and a step. So I'm going to look at just this sequence, a step of 2 and a starting seed of 14. I'm having troubles with this. Okay, so at 14, we are going to start with division. We're going to ask if this term is divisible by 14. Then we're going to ask if it's not divisible by 14, then we're going to go over to minus. Then we're going to go to plus. Then we're going to go to multiplication. So we're going to go through these sequentially. 14 is indeed divisible by 2. That's 7. You must end up with an integer more than 0 that you have not discovered so far in the sequence. So this is a recommend-like sequence. Does someone want to help with the flickering here? Okay. Next, we go to subtraction. We get to 5. 5 can't be divided by 2 to give an integer, but it can be, you can subtract 2, you get to 3, again, 1. Now the only thing you can do now is multiplication. So we're up to 2, and we go to 4, 6, 8, 10, 12. From 12, the only place to go that we haven't gone to before is 24. You can't go to 14. We've already been to 14, so we're up to 24. And I'm just going to take you on a wild ride. And we end up at 20. Can you use division by 2? No, we've already hit 10. Can you use subtraction by 2? No, we've already hit 18. Can we use addition by 2? No, we've already hit 22. Can we use multiplication by 2? No, we've already hit 40. So this sequence terminates very elegantly. And so I'm going to fill that slot in for the class. This grade 3 class is going to choose that cell to fill in red to indicate that it terminates. The next sequence, I'm going to give you 10 seconds to figure out what I was trying to do here. Any takers? Yes. Yes, so I'm connecting two numbers that have to be squares. Was I successful? No. 21 and 22 do not add to squares, so I could not complete this. I love showcasing my failures in front of students. This is one of them. Here is a success which I do not show students. Students would start off by naming a number typically under 10. Is this possible to solve? Well, the 8 would need to go to 1. 8 plus 1 is a square number. Then I could go 10 to 6. That would be 16, a square number. 9 to 7, that would be a square number. 5 to 4, square number. But again, I'm failing, and in fact, 10 is impossible. So this is the numbers for which 2n are possible. This was a new sequence discovered and played with at last year in Banff. We start off, this is going to be A2 that we look at here, so we're going to be adding the fraction 1/2. We get to 3/2. On each subsequent step, you must either add 1/2 or you must take the invert. And you have to try to get back to 1 as quickly as possible. So here we can go up to 4 over 2 or 2 over 1, and we can flip it over. That's another step. Then we get to add another half. We're at 2. So this took us, A2 is less than or equal to 4 steps. A2 less than or equal to 4. Here is for 6. So we're going to be adding 1/6. And then we're going to be either adding 1/6 or taking the inverse. 8/6, 9/6. Then I'm going to flip it to 2/3, adding a 6th, adding a 6th. So A6 is less than or equal to 6. Boomerang fractions. The grade 6 problem, you might think that this is going to be a prime factorization tree, and it's related, but there's additional constraints. This is called integral fission, and you might start with a number 88. With prime factorization, you can choose how to factor that any way you want, but that's not true for integral fission. For integral fission, your largest number must be on the right. So here, that is the only correct way to split those. However, the 22 is too heavy. You need to split these as equally as possible. So this is the only way to go from 88. Then again, you split 8 into 2 and 4. The 4 must go on the right. Then the 4 splits, and this is the pattern for 88. It is actually the first time that this pattern appears. And the sequence for grade 6 is to explore which numbers, as you're going from 2 up to infinity, which numbers do you experience a pattern for the first time? So these are those numbers, 2 and on up, and this is the worksheet that they play with. That is the grade 6 sequence. I'd like to thank Nancy Blackman and the American Institute of Mathematics for sponsoring Math Pickle.